Okay, I decided to create this little video to go through the example for assignment number 3, determining pressure in a fluid. Okay, so we are going to be looking at how to find pressure. The formula for pressure that we learned in our notes is that pressure is the force per, which means divide, unit area. Now, for SI units, force is measured in newtons. Area is going to be measured in meters squared, and that way the pressure will be in pascals. Now remember, we said a pascal is actually a very tiny amount of pressure. So a lot of times they will give you the pressure in kilopascals. Just remember, 1 kilopascal is 1,000 pascals. This is your equivalency, your conversion factor, okay? But basically, if you have kilopascals, all you have to do is say whatever the number is here times 1,000 pascals. So add 3 zeros to it, in other words, okay? All right, now, let's look at the example below, and you're going to watch this video, and then you're going to practice the same process on the other problems below the example. There are 4 for you to do. Now, there are 3 things you must show. The formula that you're going to use, I don't care that it's the same formula, it may have to be rearranged. Show it. You're going to show me the data plugged in so that I know you know how to correctly identify it, and the answer with the correct units for each of the 4 problems. That's going to be 1, 2, 3, 4 points. 1 for the formula, 1 for the data plugged in, 1 for the answer, 1 for the units. 4 points per problem for 16 points total for the assignment, okay? Now, let's look at the example real quick. You have a balloon filled with helium gas. We like them when they're filled with helium because then they float on the strings, right? The inside surface area of the balloon is 0.093 meters squared. That's about an average sized balloon you blow up for a party. If the helium exerts a force of half a newton on the inside surface, then at what pressure is the helium inside the balloon? All right, so if this is the pressure of the helium inside, then for every meter squared, it's going to exert 0.5 newtons of force. We want to know the pressure. Now, let's look at the balloon for a minute. When you have a balloon filled with helium, the helium pushes out on the inside surface. Okay? The air pressure outside pushes in on the balloon. When the two balance, the balloon stays inflated at the size you see it. Okay? Now, if one of the pressures is greater than the other pressure, all right, the balloon will shrink if the air pressure is greater, and it will expand if the air pressure outside is less than what's inside. In fact, that's what happens when you release an elastic balloon, not a Mylar balloon. A Mylar balloon can't expand, it's not elastic. But if you release an elastic balloon into the atmosphere, as it rises through the air, going higher and higher above the surface of the earth, the air pressure decreases around it. The air gets thinner and thinner, so it can't push as hard on the balloon. In that case, the helium pressure inside is greater than the air pressure outside, and the balloon expands out. Now, at some point, the air pressure outside is so small that the helium pressure inside expands the balloon to the point where the elasticity of the material cannot stand the strain, and it pops, okay? That's what happens when a balloon rises through the atmosphere. Kind of cool. Now, we want to know what's the pressure inside this particular balloon if it's exerting this much force on the inside surface area of the balloon. Well, let's take a look. The first thing we do when we solve a problem is we identify the given measurements. So let's go up here and underline them. We have two numerical pieces of information. There they are. So right here it says the surface area. So that's A, the area. And it's 0.093 meters squared. Now, I'm not going to require you to do these two steps on the problems below. What you can do is just do what I did, underline the numbers, and just put the letter for that right over it, right in the problem. It makes it a lot easier. Okay, the other value is 0.5 newtons, and that is the force exerted on the balloon. So you can write it out, or you can just put an F right over it so that you know what it is. Now, we're trying to find what? Well, it says what pressure. We want the pressure. Okay? So we want to find P. So we put a P there with a question mark. You can either put it somewhere by the problem, or you can put it right in the problem itself so that you know. Now we write the formula that goes with this, and we have it right here. Well, here's the symbol form. Whoops, right here. Okay? All right? Here's the symbol form. So we're going to say P equals F over A. That's what we're going to follow. Okay? All right. Now, the next step, now that we've written the formula, we're going to show the data plugged in, and we've identified it. F is 0.5 newtons. And we're going to divide that by A, which is 0.093 meters squared. Okay, so look what the answer for the units are going to be. Newtons per meter squared. And a Pascal is a Newton per meter squared. So we're going to be just fine. All right, so now we write the answer with the correct units. So here's where you get your calculator. I don't know if y'all can see that or not, but I'm going to put it in there. 0.5 divided by 0.093, enter, and we get, well, it says 5.376, okay? I'm going to round that to, from 5.376, I'm going to round that to 5.4. All right, so here we go. P equals 5.4 newtons per meter squared, or pascals. Okay? All right, so what I'm going to require you guys to do are these three steps right here. You can do these two right up here in the problem. That's no big deal. You don't have to write it out like this. You can just do it right in the problem. But these three steps are a must. A point, a point, a point, and a point. Get it? 4 points. Now, this is not difficult, and you can do it. However, one thing I want to remind you, what if it's not the pressure you're looking for? What if you're given the pressure? Or maybe you want to find the area. Maybe we should look at what this formula looks like if it's solved for one of the other variables. Okay? Well, we have P equals F over A. But if you want to find the force instead, then you have to multiply the A over, so you get PA. So if you're looking for the force, use P times A. Now, what if it's the area you want to find? If it's the area you want to find, and here's a neat little algebra trick, you just, since it's in the denominator, where we don't want it anyway, all you have to do is switch it with the numerator on the other side. Remember, denominator means the bottom half of a ratio. A numerator is the top half, if you think of the P as being over 1. So we're going to switch the A and the P, and that's perfectly acceptable to do. I call it numerator-denominator switch trick, okay? So A would be F over P. So now, if you're looking for the pressure, you use F over A. If you're looking for the force, you use P times A. If you're looking for the area, you use F over P. Okay? All right. It shouldn't take you too long if you follow this process. Read the problem, identify the given information, identify what you're looking for, set up your formula, whichever one you're going to use, show the numbers plugged in, and the answer with the unit. Okay? Remember, force in newtons, area in meters squared, pressure in pascals. Okay? All right, guys. Thanks. Bye.